Okay, lesson 6, different forms. 6.1 is the warm-up, and it's called Which One Doesn't Belong. So your job for 6.1, this is the warm-up. You have 4 equations. You decide which one doesn't belong. There are no wrong answers here. So if one person says that A doesn't belong because so-and-so, that doesn't mean that's somebody else could pick a different answer. Somebody might say, you know what, D doesn't belong in this group because. So come up with your own observations here. Okay, but make sure you write right here. A doesn't belong because so and so. 6.3, activity 3 here. It's called using diagrams to multiply. There's a little link right here. Watch this Khan Academy video for help. I'm gonna do B, and when you get a chance, you could click on that video, and it'll take you to a Khan Academy video. So let's see here. On this activity, it says use the distributive property to show that each pair of expressions is equivalent. So let's check if this side is equal to this side. It says distributive property. There's a couple of ways to multiply binomials. In algebra 1, maybe you heard of something called FOIL. I'm not sure if your algebra 1 teacher uses FOIL, or maybe they use the area model or the box method that looks like this. You draw a little window like this. You put x plus 6 on the sides and x minus 5 on the other side right here on the lengths. Okay, so one parenthesis goes on one side and another parenthesis goes on the other side. And then I multiply here. So to fill out these boxes, these windows, I multiply just like you would finding the area of a square or a rectangle. You multiply the length times the width. So to get this box right here, you would multiply x times x. That would be x to the power of 2. This box down here, you look at 6 and you look all the way up here to the x, that is 6x. This one here is negative 5x, and this one down here is 6 times negative 5, that's negative 30. Finally, what happens here, usually these two boxes combine. So then x squared, if I put all the boxes together, it'll be x squared plus 6x minus 5x minus 30. Okay, I put all 4 boxes like this. And then these terms in the middle combine. So this is x squared plus 1x minus 30. So you see that they're a match, they're equivalent. I use the area model, but it's not mandatory. If you could do this in your head and you could look at this and be like, oh, you know what, this is x squared, this is 4x, this is 2x, this is 8. You could do that as well. The area model just organizes your work a little bit better, but it's helpful but not mandatory. For C, notice that it has 3 terms. I'm just going to set it up for you, and you're going to do this later on your own. So I have 3 terms, so that means that I have x squared, 10x, and 7. And then I have two terms here. So I put 2x and minus 1. And then I draw some windows or some boxes like this. Like this. And you do exactly what we did here. You fill out all of these boxes, and then you combine like terms, and the answer should be this polynomial should be your answer. You just got to confirm that with this process right here. Questions on 6.3? No? All right. Okay, again, I'm just going through I'm walking you through the assignment, and later you go back and finish it. 6.4, Desmos. There's going to be a link here for the Desmos calculator. So what you're going to do, it says spot the differences. Here's one polynomial and here's another polynomial. Use a using graphing technology, either a graphing calculator or easier is the Desmos. You're going to modify the window, and I'll show you how to do that right now. And you're going to describe the two graphs. Describe how the two graphs are the same and how they're different. Right here, you'll make a sketch of your graph, and down here you'll give me a statement of what do they have the same, what do they have different. So if you go to desmos.com, you put you could either put f of x or you could put it like this. I already did it here. You put y equals parentheses x minus 2. You put all of that. You get this graph here. Now, let me show you how to change the setting. This is how you change the setting. There's a little settings or little wrench tool here. You click it, and the question says, change the window so that x goes from -10 to 10. So I'm going to go to my x coordinate here, and I'm going to modify this to go from -10 to +10. Okay, so notice that the x axis, the maximum you see is -10, or the minimum you see is -10, and it goes all the way to +10. And then the y window, you change it from -100 to 100. So I go back over here, -100, +100, and now you have fixed the window. Now you see the window that they were telling you right here. And then you would put this other equation in there and graph them in the same coordinate. So let me see. That would be y equals 1/2 is 0.5, and then it's x minus 2. Oh, x minus 2, and then it's x plus 3, x minus 7. Okay, so the blue graph is the second equation, and from this picture you're gonna describe what do they have the same and how are they different. That's your own observations. All right. And the last activity, that was 6.4. Oh, so 6.4 has two questions. That was question number one. Question number two is right here. And it's almost like this. We're gonna do the same thing as this area model or this box method here. Question number two says the degree to these what degree do these polynomials have? I can't tell what the degree is because these are in factor form. In factored form, you can't tell right away what the degree is. And remember, the degree is the highest exponent or the biggest power. Right now, the biggest power for all of them is 1, but we don't know the actual degree until we multiply it. So this is how you do it. Um, this one looks a little bit easier. I'll do this one. I'll do g of x. Okay. So what I'm going to do here, this one has a 1/2. What I'm going to do here, I'm going to distribute it inside to this first parentheses. So then that looks like 1/2 x minus 1/2 times 2 is 1, x plus 3, x minus 7. So right here you have 3 parentheses. Take any 2 parentheses that you want. If you want to take these 2, then that's fine. Take these 2, multiply them out. 3 times x is 3x. Right here is negative 7x. And right here, to get this box, you multiply 3 times negative 7. That's negative 21. Combine like terms right here. So this would be x squared minus 4x minus 21. And I bring down that first parentheses like that. And you do this one more time. You put x squared minus 4x minus 21. And then this 1/2 x minus 1, I put it right here. And I fill it out again. So this would be 1/2 x to the third. This would be 4 times a half. That is 2, negative 2x. Right here would be negative 21 over 2x. I'm multiplying the number on the side with the number at the top. This one would be negative x squared. Negative 4x times negative 1 is positive 4x. And then negative 21 times negative 1 is positive 21. Okay? Now, from right here, you could tell what the degree is. The degree is going to be 3. That's the biggest power. So for g of x, the degree is going to be 3. And then it says rewrite each expression in standard form. So in standard form, you want to make it look like this. You want to put the biggest exponent first. So first the 3, then the 2. Oh, I missed something here. No, I missed a power of 2 right here because negative 4x times 1/2 x times x is x squared. So then I could combine these right here. That would be negative 3x squared. Then right here you have, let me see, you have negative 21 over 2. That's 10.5. So that's negative 10.5 plus 4. So that's negative 6.5. Negative 6.5x and then 21. So this is standard form right here. Okay. So what I did on this example with the G, you could do it with the F. Okay. So this one would be a little bit easier because you don't have you don't have a fraction with it. You just have whole numbers there. All right. Once we finish today, I'll post the video up on Schoology so you can see and review anything that you missed on this lesson overview. Okay, lesson 7. So like I said, we're merging lesson 6 and 7. We selected from lesson 7, we selected the third activity called What's the Equation? Write a possible equation for a polynomial whose graph has the following horizontal intercepts. Check your equation using graphing technology. So you could use Desmos to verify your answer, but the idea here is working backwards. You're working backwards. Here, let me do number 2, but this is what's going on. This is x comma y. So that means that negative 2 comma 0 means it has an x-intercept at negative 2. 0 comma 0 means that there's an x-intercept at 0. 4 comma 0 means there's an x-intercept at 4. So you saw what I did there? The first number is the x-coordinate. That means, and since they all have a 0 on the y-coordinate, that means that the graph crosses the x-axis at negative 2, at 0, and at 4. That's what we did so far. But we're trying to see what was the equation that created these three x-intercepts. Well, we work backwards from the zero product property. So look at what I'm going to do here. If I know that the x-intercept was negative 2, then I know that this factor x plus 2 was the one that caused an x-intercept at negative 2. This one has a 0. It's technically like x plus 0 or x minus 0. Or you don't need to include the 0. You could just leave an x right there. And finally, the x equals 4, it would be x minus 4. You get the opposite sign. So if this is positive 4, inside the parentheses, you put a negative. Look what we did over here. On this one, it was negative 2. On the parentheses, we change it to a positive 2. So this is a possible equation that created this, that would create this graph with these x-intercepts. You could check that on Desmos. If you put this on Desmos, you're going to get a graph that crosses at these 3 spots. And just for practice, right here for number 3, the x-intercept would be x equals negative 4, x equals 0, and x equals 2. and then you would put the parentheses. And inside of the parentheses, you change the sign. So if this is -4, then you go to +4. This for 0 doesn't matter. You don't have to put nothing there. And then this is -2, -2. Okay, and you could call this g of x. Number one, you try it on your own, and you could use the Desmos calculator to put these equations so that you could see that they do cross at those spots. You have the lesson summary for lesson 6, and it is highlighted for you, very important. Here's what factor form looks like with these parentheses, and standard form, you look at the power and you go from big to small. So it's 5. If there's no 4, you skip 4, and then it's 3, and then it's 2, and then it's 1 and 0. That's standard form. And remember that the number in the front here is called the leading coefficient. The leading coefficient is right here. All right. And finally, lesson 7, the takeaway for lesson 7 is working backwards. Here's the example. They're telling you that on the summary, they're saying that -1, 2, and 4 are the x-intercepts. So they're saying x equals -1, x equals 2, and x equals 4. Right here, right here, and right here are the x-intercepts. You could create an equation out of this by putting them in parentheses by factors or the products. So this would be x plus 1, x minus 2, and x plus 4. That's how you got, oh, x minus 4, sorry. X minus 4. That's how you get this one over here. All right, that is it. Let me